Have you ever wondered if time, as we perceive it, is an illusion? That question has crossed the minds of some of the greatest minds in history, including the legendary physicist Albert Einstein. He once famously wrote that the distinction between past, present, and future is only a stubbornly persistent illusion. Let's unpack what Einstein meant by that. When we speak of time, we often think of it as a river, constantly flowing from the past through the present and into the future. But that's not quite how scientists see it. In the realm of physics, time doesn't flow, it simply is. All moments, past, present, and future, exist simultaneously. According to Einstein's theories of relativity, there is no objective now. What we perceive as now depends on where we are and how we move concerning other things. This divergence between our everyday understanding of time and our scientific understanding can be challenging. We're so accustomed to thinking of time as a linear progression, a ceaseless march from yesterday to today to tomorrow. But that's not the reality, at least not according to the laws of physics. This difference in perception isn't just a philosophical musing. It has genuine implications in fields like astrophysics, where understanding time is critical to understanding phenomena like black holes and the universe's expansion. And yet, despite the scientific consensus, this illusion of time is incredibly persistent. It's ingrained in our language, thinking, and world perception. It's almost impossible to imagine a world without the flow of time, without the distinction between past, present, and future. So, if our perception of time isn't accurate, then what is time? Imagine being near a black hole. Would time still tick away as it does here on Earth? Well, the answer is a fascinating one. The concept of gravitational time dilation, a cornerstone of Einstein's theory of relativity, suggests that time behaves in ways that defy our everyday understanding. So let's delve into this. Gravitational time dilation states that objects with more mass create a stronger gravitational field and has a profound effect on the fabric of space-time, causing it to warp and distort. But what does this mean for time? Essentially, time itself is influenced by this warping of space-time. The greater the gravitational field, the slower time passes. Consider this scenario. If you set up a clock at the base of a mountain and another at the peak, time would tick away more slowly for the clock at the base than at the peak. This effect, albeit minuscule on Earth, becomes significant when we venture into the cosmos, where gravitational fields are much more substantial. Now let's return to our original question. What would happen to time near a black hole? A black hole, with its massive gravitational pull, distorts space-time to an extreme degree. So for an observer near the event horizon of a black hole, time would appear to slow down, and at the brink of the black hole, it would seem to stop entirely. This is a mind-bending concept indeed. Time, as we experience it, is not a universal constant. It is not the same everywhere and does not progress at the same rate for everyone, influenced by gravity and speed. So, if you ever find yourself near a black hole, don't be surprised if your wristwatch begins to lag. It's not broken, it's just experiencing the gravity of time. In other words, time isn't a constant. It can slow down or speed up depending on where you are and how fast you're moving. Now, think about traveling at high speeds, close to the speed of light. What would happen to time then? Well, let's take a quick trip to the cosmos. Imagine you're an astronaut on the International Space Station, which is moving at a whopping 17,500 miles per hour. That's pretty fast, right? Now, according to the theory of relativity, the faster you move, the slower time passes for you relative to someone stationary, which is a phenomenon known as time dilation. So while you're up there zipping around the Earth, time is passing slower for you than for the folks down here on terra firma. But how is this possible? Well, it all comes down to how space and time are woven into the cosmos. You see, the faster you move through space, the slower you move through time. It's a cosmic trade-off, if you will. Now, this isn't just theoretical mumbo-jumbo, but has been measured and confirmed. The astronauts on the International Space Station, for example, age slightly slower than people on Earth. We're talking fractions of a second here, but it's a natural, measurable effect. But what about near the speed of light? Well, if you could somehow reach those incredible speeds, time would nearly stop for you. You could zip around the galaxy, and when you returned to Earth, you'd find that while only a few years had passed for you, centuries, or even millennia might have passed for everyone else. So time dilation isn't just a cool sci-fi concept. It's a fundamental aspect of our universe. It shows us that time isn't a fixed, unchanging entity. It can stretch and shrink, speed up and slow down depending on how fast you move and where you are in the universe. So not only does gravity affect time, but speed does too. Time, it seems, is not as straightforward as we thought. But if time can be warped and twisted, does it exist? This intriguing question has sparked much debate in the scientific community. Some physicists believe that time, as we understand it, may not exist at a fundamental level. Now, this might seem like a paradox. After all, we experience time every moment of our lives. We watch the hands of a clock move, we see the sun rise and set, and we grow older. But these are all characteristics of our perception of time, not time itself. Let's take a moment to consider another aspect of our reality: solidity. When we touch a table or a wall, we perceive it as solid. But we know from physics that this solidity is not fundamental. We're experiencing the electromagnetic force of the particles in our hand interacting with the particles of the table or wall. The table or wall isn't fundamentally solid. It consists primarily of emptiness. We only perceive as solidity with our limited senses. Similarly, time might not exist as a fundamental property of the universe. Instead, it may be an emergent property, something that arises out of more essential elements of reality. Just like solidity emerges from the interactions of particles, time might emerge from the interactions of whatever makes up the fabric of the universe. This concept is known as emergent time. It's a potentially revolutionary idea in the field of physics. If true, it could reshape our understanding of the universe and our place within it. However, it's important to remember that this is still a theory, a part of ongoing scientific exploration. Our understanding of time and its nature continues to evolve as we delve deeper into the mysteries of the universe. So time might not be a fundamental aspect of our universe, but an emergent property, much like the solidity of everyday objects. If time is an illusion, what does that mean for our understanding of past, present, and future? This question brings us to the heart of Albert Einstein's revolutionary ideas about time. Einstein, synonymous with genius, believed that all moments are equally real. His theory of relativity shattered the conventional understanding of time, suggesting that the future is as set in stone as the past. This idea may seem counterintuitive to our everyday experience, where we perceive time as constantly flowing and the present moment as ceaselessly updating itself. But in Einstein's universe, there's no such thing as absolute simultaneity. He proposed that time, like space, is relative to the observer. Depending on where you are and how fast you're moving, time can appear to speed up or slow down. This is a theoretical idea and a physical reality confirmed by countless experiments. So what does this mean for our perception of past, present, and future? If all moments are equally authentic, then the past, present, and future coexist in the space-time fabric. They are all out there, just waiting to be experienced from different perspectives. The past is not gone, the future is not yet to come, and the present is not the only reality. They are all intertwined in the complex tapestry of time. Einstein's view of time as a persistent illusion challenges our everyday understanding of the world. It forces us to reconsider our perceptions, actions, and entire existence within this relative universe. But it also opens up a world of possibilities, a universe filled with multiple realities and infinite timelines. In Einstein's universe, the past, present, and future coexist, challenging our everyday understanding of time. It's a profound thought that invites us to explore the mysteries of time and perhaps uncover the secrets of our existence. So, we've journeyed through the complexities of time, but what does all this mean for us? We've learned that time, as we understand it, is an illusion, defying our everyday perception and presenting a fascinating enigma. Delving into gravitational time dilation, we discovered that objects with more mass can warp the fabric of space-time, altering the passage of time. We've also explored the intriguing concept of time dilation at high speeds, a phenomenon experienced by astronauts aboard the International Space Station. We've also pondered the concept of time as an emergent property, a revolutionary idea that suggests time may not exist at a fundamental level, but appears at higher levels. Finally, we've delved into the coexistence of past, present, and future. This concept challenges our linear understanding of time and echoes Einstein's view of time as a persistent illusion. While time may be a stubbornly persistent illusion, it's an illusion that shapes our reality. So the next time you glance at your watch, remember, time is not as it seems. Thank you for joining us on this journey through time. If you enjoyed this video, please give it a thumbs up and subscribe to our channel for more thought-provoking content, and stay curious.